Good afternoon, dear students. Yes. So, in the last class, we have seen what are ethers, right? So, in the previous class, we have seen what are ethers and we have seen the structure of ether, okay, the functional group. So, that is, it has a O linkage, right? Then also we have seen the classification of ethers. That is, the ethers are classified into two types. The firstly, simple or symmetrical ethers, and the second one is mixed or asymmetrical ethers, right? So unsymmetrical ethers. So we have seen the examples also based on that, right? So then we had seen the functional group, that is the structure of functional group. So So in this ethers, okay. So then we had to start with the this what nomenclature. So let us see about the nomenclature and then we'll proceed to the methods of preparation. Okay. So firstly, let us see the nomenclature of ethers. So ethers, okay. So common names of the ethers, how they have derived? They have derived from the alkyl or the aryl group. Okay. So you have to write the alkyl or the aryl group as a separate words in alphabetical order. First, you have to write the alkyl or the aryl word. Okay. And then followed by the word ether. Suppose, example, if I have CH3O, CH3. So what I have a methyl group. Okay. So how many methyls are there? So when you have more than one methyl, then how do you represent di, tri, right, tetra? So like that. So this is a dimethyl. Okay. And then followed by the name word ether. Okay. So this is the example. Another example, C2H5O, C6H5. Okay. So this is an example of a unsymmetrical ether. So how do you name this? This is a ethyl group. This is a phenyl group. So which comes first? First comes your ethyl. So you have to write ethyl, then comes your phenyl group, and then comes your ether. Okay, so like this. Suppose C2H5O C2H5. So this is two ethyl groups. So two ethyl groups. So it is a diethyl ether. Okay, like this. So like this, you have to name in common system. So this is on in the common name system. Okay, when you have a common system. Let us go for the next one. That is a IUPAC system. When you have IUPAC system, IUPAC name system. So how do you write in IUPAC ethers? So according to IUPAC, so ethers, how they are named as? They are named as alkoxy alkanes. Okay, they are named as what? Alkoxy alkanes. Okay, they are named as alkoxy alkanes. So the larger R group, so whichever the R group will be larger, right? It is taken as a parent chain. Okay, it is taken as what? It is taken as a parent chain. Okay. So is it clear? Okay. So it is taken as a parent chain hydrocarbon. So let us go for the naming now. So I'll write the names of the compounds. You have to tell me the IUPAC name as well as the common name. Okay. So C2H5, O, C2H5. CH3O, CH2, CH2, CH3, then CH3O, CH, CH3 twice, C6H5O, CH3, C6H5O, CH2, CH3. Okay. Name this. Yes, name this. Yes, what is the name of the first compound? Can you tell the common name? Common name of the first compound and the IUPAC name. Yes, what is the common name? It is what is the common name? It is methoxymethane. Okay, that is the your IUPAC name. Okay, it is a IUPAC name, that is methoxymethane. Okay. What about the common name? It is dimethyl ether. Right. Okay, let's go for the second one. Second one.
Diethyl ether.
Yes, diethyl ether. And the IUPAC name?
Ethoxyethane.
Yes, it is ethoxyethane. Okay. Next one. Next one. So this is 1, 2, and 3 carbon. So this is a propyl group. This is a methyl group. So which comes first?
Methyl.
Yes, so it is methyl propyl ether. Okay, can you tell the IUPAC name now? So whenever the carbon chain is bigger, so that you have to check that substituent should be taken as a parent chain. So here it is propane. So what will be that? It will be 1-methoxypropane. Okay. So in between the substituents CH3 and this group, so this is a larger hydrocarbon. So this should be taken as a parent chain hydrocarbon. Okay. Next compound. Important, asked for exams for 1 mark. Give the IUPAC name of the following compound. So this can be as C6H5. Okay, this particular CH3O, CH3 twice. So it is CH3O, CH3. Okay, can you tell the name now? So if you name the carbon, this is 1, 2, and 3 again. So it is methyl isopropyl ether. Right. Then IUPAC name 2-methoxypropane. 2-methoxypropane. Okay. Let's go for the next one. Next one, you have one methyl group. Another you have phenyl group. So which comes first? Methyl group. So it is methyl phenyl ether. Okay. What is IUPAC name? IUPAC name is methoxybenzene. Okay, methoxybenzene. Okay, and it is called as anisole. So how it is represented like this: benzene ring and OCH3. So the name of the compound is commonly called as anisole. Okay, it is called as anisole. Okay, let's go for the next one. Here you have one ethyl group and you have phenyl group. So which comes first? Comes your ethyl group. So it is ethyl phenyl ether. Okay, then IUPAC name? IUPAC name? Ethoxybenzene. Okay, so like this, you have to name the compounds. Fine. Let us go for the next one. C6H5O CH2 6CH3. Okay. Next one, CH3O CH2 CH2O CH3. One more. Last. CH3 CH3O C2H5. Yes. Name. Tell the name of the compound. So this is a phenyl group, and here this is a 7 carbons are there. So it is a heptane group. Okay, this is a heptane group. So what is the name? This is heptyl. Okay, H come first. Heptyl phenyl ether. Okay, the IUPAC name 1-phenoxy heptane. 1-phenoxy heptane. Okay, next one. Next one. Next one. You can tell the IUPAC name for this. It is 1, 2. Okay, at 1, 2 position, you have what group? You have 1, 2 dimethoxy. Okay, 1, 2, 3, 4. So it is 1, 2 dimethoxy ethane. 1, 2, and this is dimethoxy ethane. Okay, next compound. Next compound. IUPAC name. 1, you have methyl and ethyl. So 1 becomes a ethyl group. So 1 ethyl, then 2, 2 dimethyl cyclohexane. Cyclohexane. Is it? Got it? Got the names? Okay.
Yes, ma'am.
So we have completed the classification, structural, that is the structure of functional group and nomenclature. So let us start with the methods of preparation of alcohols. That is your ethers. Okay. Methods of preparation of ethers. Okay. So the first reaction is dehydration of alcohols. Okay, so by doing dehydration on alcohols, what we obtain? We obtain this ethers. Okay, so methods of preparations of ethers. So by dehydration reaction. Okay, by dehydration of alcohols. By dehydration of alcohols. Okay, so alcohols, what they can do? They undergo dehydration. Dehydration means what? Removal of water molecule. Okay, removal of water molecule. So how this dehydration takes place? So this is your alcohol. Okay, this is your alcohol. So what we are doing in the presence of acid. So whenever you may have concentrated acid, suppose we have concentrated H2SO4. So this concentrated H2SO4, it acts as what? It acts as a dehydrating agent. So remember that what is concentrated acid? So concentrated acid, that is your H2SO4, it is acting as a dehydrating agent. Okay. So dehydrating agent, which is a dehydrating agent, it is a concentrated H2SO4. So when we are taking alcohol to that, when we are adding concentrated H2SO4, what happens? This OH, okay, the H plus ions from this, okay, your OH will attack, it will attack, and this will be protonated. Okay, as it is protonated, what will happen? It will give you alkenes or ethers, depending upon the reaction condition. So depending upon the reaction condition, so you can see, okay, if the reaction is it is taking place at 100 degree. Okay, so what happens? Your HSO4, okay, so your OH is replaced by the HSO4, okay, the negative ion of the H2SO4. Okay, so this is a product of it. If the reaction condition is at 413 Kelvin, okay, if it is at 413 Kelvin, then you obtain a ether. So at this particular condition, you obtain a ether. And if you at a higher temperature, okay, at a very high temperature, that is from 433 to 444 Kelvin, then you obtain what? Then you obtain a alkene. So like this, the dehydration of alcohols takes place. Okay, so depending upon this condition, okay, depending upon the condition, or you can say reaction condition, the alkenes or ethers are produced. Okay, so at 433 Kelvin or 443 Kelvin, you get your alkene, and at 413 Kelvin, you obtain the ether. Okay, so alcohols, when you react it with excess of acid, concentrated acid, you obtain ethers or alkene respectively. Okay, fine. So this is a first reaction, that is by dehydration of alcohols. Okay. by dehydration of alcohol. Next is by Williamson's ether synthesis. Okay, by Williamson's ether synthesis. So what is Williamson ether synthesis? When a alkyl halide, okay, this is your alkyl halide. So when your alkyl halide reacts with sodium alkoxide, when the alkyl halide reacts with sodium alkoxide, okay, it will produce ethers. It will produce what? It will produce ether. So just a second. I do this. So can you tell me what will be the product? It will be RO R dash plus NaX. Okay, so what we obtained? We obtained a ether. What we obtained? We obtained a ether. So when alkyl halides, when it reacts with what? When it reacts with sodium alkoxide, what we obtained? We obtained a ether and sodium, that is sodium halide is obtained. So this is a very important reaction, Williamson ether synthesis. Okay, so the question can be asked, explain Williamson's ether synthesis with examples. So this is a question asked for 2 marks. Okay, so let us take an example now. You have to tell me the product obtained. Okay. So we have taken what? We have taken a ethyl chloride. This is a ethyl chloride. We have reacted with what? We have reacted with the sodium or methoxide. Sodium methoxide. Okay, can you tell me what is the product? What will be the product, students? So your Cl will get attached with your NaCl. Okay, so NaCl is formed. And what is the product obtained, students? Ethyl fluoride when it reacts with sodium methoxide. So this is a Williamson ether synthesis. So in this method, you can prepare symmetrical as well as both. Okay, mixed, that is symmetrical as well as unsymmetrical ethers can be produced by this method. Okay, what is the product obtained, students? NaCl is left. Okay, Na and Cl will combine to give you NaCl. What is the product? It is C2H5OCH3. Right. So what is that? It is a ethyl methyl ether. Okay, you obtained a ethyl methyl ether. Got it? Yes. So like this is the Williamson ether synthesis. So Williamson ether synthesis, you can produce both simple as well as mixed ether can be produced. Okay. One more example. Here you can see CH3CH2I. So this is an ethyl iodide. So this is an ethyl iodide. So ethyl iodide, when it reacts with your sodium, okay. So this is a sodium benzoxide. So phenoxide. Okay, you can take it as sodium phenoxide. So when it reacts with sodium phenoxide, what we obtain? Yes. So Na will combine with X. Okay. And you will get what? OCH2, CH3. Right. So what we got? We got ethyl phenyl ether. What we got? Ethyl phenyl ether. Got it? Yes. So this is the reaction. So when your ethyl iodide reacts with sodium phenoxide, okay, what we obtained? We obtained a ethyl phenyl ether. So Na will get combined with I. You get Na iodide plus benzene, okay, the oxygen and connected to CH2, CH3. So it is a ethyl phenyl ether. What it is? Ethyl phenyl ether. Okay. So very important reactions. So these are the two named reactions. That is a two important reaction. One is a dehydration of alcohols. So with specific condition, you can obtain your alcohols. That is you can obtain your alkenes as well as the ethers. Okay, and another is Williamson ether synthesis. So from Williamson ether synthesis, you can prepare both your symmetrical as well as unsymmetrical alkenes. Got it? Okay. So next is the physical properties. Okay, next we are going to discuss about the physical properties of ethers. So what is the physical properties of ether? So first is the dipole moment. So physical properties, first is dipole moment. Okay, first is dipole moment. So we know that how is the structure of ether. So this is the structure of ether. So it has an angular shape. Okay, it is an angular or it is having a bent structure. Okay, so ethers have what? It has a angular or bent structure. Okay, so the CO bond, that is your this bond. Okay, in ethers it is polar. Okay, it is polar. Okay, so the CO bond is polar. So as a result, they have a net dipole moment. So they have a net dipole moment. Got it? Okay. So what is the physical property? First physical property is your dipole moment. So this is the structure of ether. So you can see that it is having an angular or bent structure. And you can see that the carbon oxygen bond, it is polar in nature. And because of that, the net dipole moment, so there is some resultant dipole moment. So it has some value. Okay. So dipole moment. So this ether. Okay. So these things you have to remember about the dipole moment. Next is the boiling point. Next is what? Boiling point. So when you are discussing about the boiling point, suppose you have CH3, CH2 thrice, CH3. So that is 3, 4, 5. So then you have what? N-pentane. You have N-pentane. Suppose you have CH3, CH2O, CH2, CH3. So again, what you have? Diethyl ether. This is what? Diethyl ether. Then next is if you have a alcohol, that is CH3, CH2, CH3. Okay, let me write it like this only. So if it is CH3, CH2 thrice and OH, so 3, 4. So it is butane 1 all. Okay, so now here N-pentane, diethyl ether and butane 1 all. So if you see the boiling point of this is 109.1 and of diethyl ether is 107.6 and of butanol is 390. Okay, so we can see that there is a weak attraction forces. Okay, weak molecular forces of attraction is between the ethers. Okay, so weak molecular forces are present in ethers, are present in between the ethers. So when you compare your ethers, okay, when you compare your ethers and the alcohol and hydrocarbons, you can see that in ethers, the boiling point is very less. Why? Because of the weak molecular forces which are present in between the ethers. Okay. As compared to the other molecules like your hydrocarbons and your alcohol, it has a lower boiling point. Okay. It has lower boiling point. Okay. You can see the N-methane, if you compare the N-pentane, diethyl ether and butane 1 all the molecular mass is same. Okay, but what you can see in case of the ether, the forces are very weak, okay, as compared to the other molecules. So in between these ethers, the molecular forces are very weak. Because of that, it is having a very low boiling point. Got it? Yes, so these are the two main properties. So next we are going to discuss about the solubility. Next is what? Solubility. What do you understand by solubility? So the solubility of ethers in water is due to the fact that, okay, the alcohols. So in alcohols, if you see alcohols, you know that it can form hydrogen bonding. It can form hydrogen bonding in water. Okay. But when you see your ethers, okay, ether can also form the hydrogen bond with this other water molecule. So like this. Okay, so the solubility, what will happen to the solubility? The solubility will go on decreasing from lower member to the higher members. Why? Because as the number of carbon atom increases, what will happen? As the size of the alkyl group increases, then there will be steric hindrance. Okay, there will be steric hindrance. And because of that, the tendency to form the hydrogen bonding will go on decreasing. Okay, as the size increases, as you are okay, as you are moving from this what from lower ethers, okay, from lower ethers to higher ethers, what will happen? The size of the this or there will be size of the alkyl group will increase. So as the size of the alkyl group increase, what will happen to the there will be steric hindrance. Okay, there will be steric hindrance. So if the steric hindrance is there, so steric hindrance also increases. Then what will happen? The atoms, they cannot form hydrogen bonding. So the tendency of the atoms to form the hydrogen bonding will decrease. So this is about the solubility. So when we see the density, okay, all the ethers are lighter than water. Okay, what is density? Density is equals to mass by volume. Okay, so when you compare the densities of the ethers and other molecules, so ethers, okay, they are lighter than when you compare your water molecule. Okay, so this is about what? This is about your ethers. Okay, so next we are going to discuss about the chemical properties. So let us start with the chemical properties. So these are the four important physical properties. So we have discussed about boiling point, we have discussed about solubility, density, and the dipole moment. Okay, so these are the four important points. So dipole moment, solubility, then we have seen about density and boiling point. Okay, now let us see next is the chemical properties. So first is reactions involving cleavage of CO bond. Okay, so whenever you have the cleavage, that is the breaking of bond, if it is taking place at carbon oxygen bond. Okay, if the cleavage is taking place at carbon oxygen bond, so that is called as what? So the breaking of bond takes place at carbon oxygen. Suppose this is the okay, so this is the breaking taking place. So it develops the different compounds. So let us see how the reaction takes place. First reaction is reaction with hydrogen halide. So how the ethers react with hydrogen halide. Okay, how they react with hydrogen halide. So what is hydrogen halide? HX. So if I have a ether, and I react with HX. What will be the product obtained? Yes. What will be the product obtained? So R and X will form plus ROH. So alcohol and alkyl halide is formed. Right. So alcohol and alkyl halide is formed. So when your ether, when it reacts with your hydrogen halide, what it forms? It forms a alcohol and alkyl halide. What it forms? It forms a alcohol and alkyl halide. Got it? So this is a reaction. So let me give you example. C2H5 O C2H5 plus I take hydrogen chloride. Can you tell me the products, students? Yes, tell me the products. I want the answer from you. Yes, what will be the product?
C2H5OH.
C2H5OH plus
HCl.
C2H5OH plus C2H5Cl. Here, just a second. Let me see. Write it here. Here, this will combine with your C2H5 OH. Okay, C2H5OH. Suppose if I get 2C2H5OH plus. So I can get here C2H5OH plus C2H5Cl. Right. So I get an alkyl halide. So that is ethyl chloride and ethyl alcohol. Right. Now suppose next reaction, if I take yes. So this is a tetrahydrophenol. This is a tetrahydrofuran. Okay, it is reacting with hydrogen iodide. Hydrogen iodide. Yes, can you give me the product? At 373 Kelvin. At 373 Kelvin. So what will be the product here? Yes. What will be the product? The product obtained will be what? So at this position, you will get iodine. Okay, so iodide will go and attack here. So iodine. So how many carbons? 1, 2, 3, and 4 carbons. So it is CH2, 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 and I plus H2O. Okay, so this is the product obtained. So this is when you have a symmetrical alkenes, right? You have a symmetrical alkenes. Okay, so this is a diiodobutane is produced. So alkyl halide is produced and a water molecule is produced. Now suppose we have an unsymmetrical alkene. Now we have an unsymmetrical alkene. Suppose RO R dash plus HX. Again, what you'll get? I'll get RX plus R dash OH. Okay. Suppose I have CH3C, CH3, CH3, O, CH3 plus HI, giving you. What will be the product obtained? Can anyone tell me? So the product obtained will be what? It will be okay, let me tell you. So this will be more stable. So this will form alcohol. So CH3, CH3, CH3OH. Sorry, CH3, CH3I. Okay, so this is a iodide. Plus you will get methanol. So this is a tertiary butyl iodide. Okay, tertiary butyl iodide. And the second one is methanol. Second one is what? Methanol. Got it? Yes, so this is our reaction. Okay. When you, so this is a, you can see. So how the CO bond takes place, the cleavage at CO bond takes place. Okay. So we are seeing the cleavage of CO bond. Let us go for the aryl ether. So I have one example here. Okay. Plus HX. What it will give you? Can anyone tell me what will be the product form? Yes. Can you tell me? So what is this? RX will combine and then what will we will get? We'll get a phenol. Right? We'll get a phenol. Okay. Let's take an example now. When we have a aryl this. So let us take okay plus HI. So this is a anisole. This is a hydrogen iodide. Yes. Now we'll get CH3I and OH. So this is what? Phenol plus methyl iodide. Phenol plus methyl iodide. Okay, so this is the how the cleavage of CO bond takes place. Is it clear? Yes. Is it clear up to your any
Yes, ma'am.
doubts?
No, ma'am.
Okay. So let us go for the next. Next is electrophilic substitution reaction. So let us discuss about electrophilic substitution reactions. So electrophilic substitution reactions of aromatic ethers. Okay. So here what we have, whatever the alkoxy group is there. Okay, the alkoxy group, that is your, this is your alkoxy group. So this is ortho or para directing. This is what? Ortho or para directing. So ortho or para directing. Fine. This is ortho or para directing group, and what it will do, it will activate the aromatic ring. So it will activate your aromatic ring, okay, towards the electrophilic substitution reaction. Fine. So how the reaction takes place? Okay. So let us see first one, halogenation. So before that, let me show you how it activates. Suppose I have this benzene and alkoxy group. Okay, so due to the presence of the lone pair of electrons, so this will undergo delocalization of electrons. So how the delocalization of electron takes place, just see. So these are the resonance structures. These are the resonance structures. Okay. Fine. So these are the resonance structures. So you can see how the negative charge is. Okay. So it is more stable at the ortho and para position. Okay. So let us see. So how the attack takes place. So let us see first is the halogenation. So if we consider the halogenation as the reaction, okay. So what is the our starting? We are going to take a anisole, that is OCH3. Okay. So these reactions I'll show you here. So let me see the halogenation. I'll show you halogenation. So let us take 2 moles of anisole, react it with 2 Br2. Okay, in the presence of acetic acid. What I'll obtain? I'll obtain the OCH3 Br. Okay, so this is the orthobromoanisole, and the second one is plus para. Okay, plus is the parabromoanisole. So which is the major product you have seen in the resonating structures. Okay, so the negative charge is most like balanced in the para position, right? So para position, it is a major product, and at ortho position, it is a minor product. So halogenation, so aryl alkyl ethers, they undergo halogenation in the benzene ring. Okay, So these methoxy group, whatever the methoxy group. So as we have said, the alkoxy group, it is an orthopara directing group. So what it will do, the incoming this what electrophile, it will be attacked at the ortho or para position. Okay. So what it will do, this methoxy group, it is activating the benzene ring and thus the bromination takes place. Okay. So bromination, it takes place. Got it? Is it clear up to here? Yes. Okay. So I'll give you homework. In the next class, we are going to discuss about nitration and Friedel-Crafts reaction. So before that, I'll give you some homework. So take the question, write the reaction of Williamson's synthesis of 2-ethoxy 3-methyl pentane starting from ethanol and 3-methyl pentane to all. Okay, 3-methyl pentane to all. Got it? Got it? Yes? Okay. So this is about the first question. And take second question. Which of the following, I'll repeat it. Okay, I'll just dictate. Please write it down. Which of the following is an appropriate set of reactants? Okay, which of the following is an appropriate set of reactants for the preparation of 1-methoxy 4-nitrobenzene and why? So this is your compound, okay, plus CH3ONA and this is. So which can form this particular compound, that is 1-methoxy 4-nitrobenzene, and what is the reason? Is it clear? Okay. Fine. So these are the two questions. So go to the questions. Okay. And tomorrow I want the answers from you. Okay. Fine. So is it clear up to here? Yes. So we are left with a few things. Okay. In the next class, we'll be dealing with that Friedel-Crafts reaction, nitration. Okay. And then some of the important compounds of alcohol. So let us see these all things in the next class. So for today, I'll be stopping here. Okay, let me stop it here. So we'll meet in the next class. Thank you.